Okay, students, we are here with angle proofs phase 2. Not phase 1, not phase 3, but phase 2. Alright, so it's really just another day of angle proofs, practicing our skills, seeing some new kinds of things, and just getting better overall. Alright, so let's just dive in. If you can prove this, see if you can prove this. If two lines intersect to form adjacent congruent angles, then the lines are perpendicular. And this is just a plethora of new information. Only the second day we've ever seen it. So, it might seem a little crazy, but we'll get through it. You'll learn a lot. You'll become better. So I'm just filling in my first statement and my first reason. Alright, remember, proofs are just kind of a giant pattern, and the quicker we see the pattern, the more success we're going to have. Furthermore, DAC, CAB, it told me that these angles were congruent. Great. Alright. Now I can say that they also form a linear pair. Why? Why can I say that DAC and CAB form a linear pair? But just look at it. Alright, DAC is that angle right there. CAB is that angle right there. They're clearly forming a linear pair by definition of linear pair. Alright, they're two adjacent angles whose non-common side form a straight line, or they're a pair of angles that form a line. Alright, now this one's a little goofy, but we say it anyways. I hate this postulate, but we can say that these two angles are supplementary by the linear pair postulate. You remember that goes back to buzzwords. Linear pair, supplementary, supplementary. We use it in the next one. And in fact, again, remember, this is just kind of building off what we did yesterday. Hopefully you can say, well, hold up, if they're supplementary, I can add the measure of angle DAC to the measure of angle CAB to equal 180. Alright, nice. Alright, and then this proof's a little different. It gave us a lot of reasons. We have to figure out the statements. Okay, so it's telling me substitution. So let's think. Measure of angle DAC equals a measure of angle CAB. So I can just go ahead and substitute it in right there. I can go ahead and replace it. So I'm going to get the measure of angle DAC plus the measure of angle DAC equals 180 degrees. Cool. Now it's telling me combine like terms, good old CLT, 2 parentheses, measure of angle DAC equals 180 degrees. Good old combine like terms. Like terms. Alright, now I gotta divide both sides. I can divide both sides by 2. That's mathematically legal, so I can say, well, the measure of angle DAC now equals 90 degrees. So basically, looking at this picture, that's a 90 degrees, so this is in fact a right angle. Right? So these two lines are intersecting to form a right angle. Interesting. Alright, so that means that angle DAC is a right angle by just definition of a right angle. It measures 90 degrees, and we name those right angles by definition. Alright, so even if you stink at proofs, you can't stink at filling in the last statement. It's always what we want to prove. Alright, so I'm going to say AC, line AC is perpendicular to line BD. Why? Well, their two lines intersect to form a right angle, so they're perpendicular by just definition of perpendicular lines. When two lines intersect to form a right angle, they are perpendicular. I also think something I forgot to mention really fast is I'll give you a minute to write. Okay, it's right here. This upside down T means perpendicular. So the notation for perpendicular lines is literally a pair of perpendicular lines. Alright, just like how we'll talk about this in the future, but the notation for parallel lines are literally parallel lines. Alright, so perpendicular is like an upside down T. Parallel is just like it's a vertical equal sign almost. Alright, neat. All right. Now, cruising right along, if two sides of adjacent acute angles are perpendicular, then the angles are complementary. So basically what this is saying is we got this angle chilling here, this angle chilling here. These two angles are adjacent. Why? They share this side. Also, they're perpendicular. So basically it's saying, well, those two angles are complementary. Duh, we've done problems like this in the past where we have this picture and we're solving for x and doing all kinds of crazy stuff. So it might be obvious to you that angle 3 and angle 4 are complementary, but nonetheless, we're going to prove it just to practice our skills. All right, so let's just fill in our first statement, free points, EF perpendicular to EH, given. All right, so now, what's the definition of perpendicular lines? Well, that means angle FEH is a right angle. All right, they're intersecting, they're perpendicular lines, so they're intersecting to form a right angle by definition of perpendicular lines. All right, so since it's a right angle, well, what do we know about right angles? Well, I know that their measure is equal to 90 degrees. All right, and now we have the good old angle addition postulate. So we're really good at identifying letters using, or identifying angles by using 3 letters, but they're labeled with this number like that. We can also say that as well. We can say measure of angle 3 plus the measure of angle 4 equals the whole freaking thing, which is the measure of angle FEH. So the two little angles add up to equal the bigger one, angle addition postulate. Well, then notice, FEH equals 90, FEH equals angle 3 plus angle 4. So measure of angle 3 plus the measure of angle 4 must equal 90 degrees by transitive. All right, they both equal 90, so they equal each other. Yes. All right. And then remember, our punchline where we want to end up is always what we wanted to prove. So I'm going to write angle 3 and angle 4 are complementary. Why? This will blow your mind, but they're complementary because it's the definition of complementary. They're two angles that add up to 90 degrees, which we stated in number 5. All right, nice. That was a beast of a proof, but we got through it. All right, so again, a lot of new stuff, but it's a lot of repetition as well. The patterns exist. You'll start to see them. There's only a certain amount of angle proofs we can do. This is just some of them, and we're getting better each and every video. Watch the next video to keep improving your skills.